Welcome to our channel. Today we're diving into the heart of our solar system to uncover 10 surprising facts you never knew about the sun. You might think you know the sun, that big, bright yellow thing in the sky that dictates when we go to the beach. But trust me, the sun is so much weirder, wilder, and more fascinating than you probably realize. Stay tuned because some of these facts about the sun will blow your mind. Let's kick things off with a cosmic curveball. The sun isn't actually yellow. It might come as a surprise, but the sun is, in fact, a white star. We've all seen it, that big yellow orb in the sky, glowing brightly and warming our days. But I'm here to tell you, that's just Earth playing a little atmospheric trick on us. Our planet's atmosphere is the real magician here. See, the sun emits light in all colors of the rainbow. This means it sends out a full spectrum of light from violet to red. But when sunlight enters our atmosphere, the shorter blue wavelengths get scattered more than the longer yellow and red wavelengths. This scattering effect is what makes our sky appear blue. The remaining light that reaches our eyes is dominated by the longer wavelengths, giving the sun its apparent yellow hue. This is why the sun looks yellow to us during the day. But if you could travel into space and see the sun without Earth's atmosphere in the way, you'd find a brilliant white star. The sun's true color is revealed in the vacuum of space. So the next time you're enjoying a beautiful sunset, remember, you're not really seeing the sun's true colors, just Earth's atmospheric interpretation of them. It's a beautiful illusion created by our planet's unique atmosphere. Alright, let's talk about the sun's sheer size, because honestly, pictures just don't do it justice. I'm talking about a mass so immense that it makes up a whopping 99.86% of the entire solar system's mass. It's mind-boggling. And all that mass translates into some serious gravitational pull. This is what keeps all the planets locked in orbit around the sun, like a cosmic dance where the sun calls all the shots. Think about it. Earth is constantly hurtling through space at thousands of miles per hour, but the sun's gravity keeps us from spinning off into the void. Let's get ready to experience some serious heat, because we're about to take a hypothetical plunge into the heart of the sun. Now, I say hypothetical because, well, nothing known to science could survive the sun's core. As we descend towards the sun's core, we'd pass through layers of increasingly hot plasma, each layer hotter than the last. The core of the sun is a nuclear furnace operating at a mind-boggling 27 million degrees Fahrenheit. It's this intense heat and pressure that powers the nuclear fusion reactions happening within the sun's core, turning hydrogen into helium and releasing the energy that bathes our entire solar system in life-giving light. Chapter 4. A Star in Its Prime. The Sun's Midlife Crisis. Now, you might think that something as ancient and powerful as the sun has been around forever, but even stars have a life cycle. Our sun is currently about 4.6 billion years old, which puts it right in the middle of its main sequence lifespan. During this phase, a star is happily fusing hydrogen into helium in its core, radiating energy like a cosmic disco ball. But don't worry, the sun has billions of years left in this phase. It's comforting to know that our sun is a stable, middle-aged star, not too young and erratic, not too old and about to go supernova. It's the perfect cosmic parent, providing just the right amount of energy for life to flourish here on Earth. Chapter 5. The sun's magnetic flip-flop every 11 years. Hold on to your hats, folks, because the sun's magnetic field is about to pull a 180. It extends far beyond the visible surface of the sun, creating what we call the Heliosphere, a vast bubble that encompasses our entire solar system. But here's the wild part. Every 11 years, the sun's magnetic field completely flips, with the north magnetic pole becoming the south pole, and vice versa. This phenomenon is all part of the sun's natural cycle known as the solar cycle. During this cycle, the sun's magnetic activity waxes and wanes, leading to changes in the number of sunspots, solar flares, and coronal mass ejections. These events can have a significant impact on Earth, disrupting satellites, causing radio blackouts, and even triggering stunning auroras. Chapter 6. No Solid Ground, the Sun's Gaseous Surprise. It's time to shatter another misconception about our nearest star. You might picture the sun as this giant fiery ball in the sky. But here's the mind-blowing truth. The sun isn't solid at all. It's a giant ball of plasma, a state of matter so hot that electrons are stripped away from atoms, creating a swirling sea of charged particles. Imagine a cosmic lava lamp, but instead of wax and water, it's superheated hydrogen and helium ions flowing and churning in response to the sun's immense gravitational and magnetic forces. The sun is made up of several layers, each with its own unique characteristics. Each layer plays a crucial role in transporting energy from the sun's core out into space, where it eventually reaches us here on Earth. Chapter 7. Red Giant on the Horizon, the Sun's Inevitable Fate. Now let's fast forward billions of years into the future and take a glimpse at the Sun's eventual fate. Our star, which has been a constant source of light and energy, will undergo a dramatic transformation. As the Sun continues to fuse hydrogen into helium, it gradually depletes its fuel reserves. This process, known as nuclear fusion, is what powers the Sun and gives it its brilliance. The Sun's core will contract, heating up even further, while the outer layers will expand dramatically, engulfing the inner planets, including, you guessed it, Earth. This expansion will mark the beginning of the Sun's red giant phase, but don't worry, this won't happen for another 5 billion years or so. We have plenty of time to prepare for this cosmic event. During this red giant phase, the Sun will swell up to hundreds of times its current size, becoming a luminous giant casting a reddish-orange glow across the solar system. This phase will be both beautiful and destructive. It's a dramatic transformation, but one that's inevitable for stars like our Sun. This is the natural life cycle of a star. Our planet will eventually be swallowed by the Sun. This will be the end of Earth as we know it. Plenty of time to update your calendars. Until then, we can continue to marvel at the Sun's brilliance and the life it supports. Chapter 8. 8 minutes to Earth. The cosmic speed limit. Have you ever looked up at the Sun and wondered how long it takes for its light to reach us here on Earth? It's a journey of millions of miles across the vast expanse of space. In fact, it takes about 8 minutes for sunlight to travel from the Sun to Earth. The light hitting your face right now left the Sun 8 minutes ago. It's like a cosmic time delay, a reminder that we're always looking at the Sun as it was in the past. And that's because light, despite traveling at the fastest speed possible in the universe, still takes time to cover vast distances. It's like having a time machine, allowing us to peer into the distant past of the universe. Chapter 9. Cool spots on a hot star. The Mystery of Sunspots. Now for a phenomenon that might seem a bit counterintuitive, sunspots. These dark blemishes on the Sun's surface are actually cooler areas, thousands of degrees cooler than the surrounding photosphere. Sunspots are regions of intense magnetic activity, and these magnetic fields are so strong that they actually inhibit the flow of heat from the Sun's interior. Sunspots are formed when these magnetic field lines become twisted and tangled, creating areas of reduced temperature. And don't let their cooler temperatures fool you. Sunspots are still incredibly hot. These dark spots are a testament to the Sun's dynamic and ever-changing magnetic field, a force that drives much of the Sun's activity. Chapter 10. Solar Wind and Earth's Light Show, the Northern Lights. Let's wrap up our journey with a phenomenon that connects the Sun to Earth in a truly spectacular way, the Northern Lights, also known as the Aurora Borealis. This natural light display is one of the most mesmerizing sights one can witness, often leaving viewers in awe of its beauty. These shimmering curtains of light dancing across the night sky are a direct result of the Sun's constant stream of charged particles called the solar wind. This solar wind travels millions of miles through space before reaching our planet. When this solar wind reaches Earth, it interacts with our planet's own magnetic field, creating a celestial ballet of light and color. The magnetic field channels these particles towards the polar regions, where the magic happens. As the charged particles from the Sun collide with atoms in Earth's atmosphere, they excite these atoms, causing them to release energy in the form of light. This process is what gives rise to the stunning visual display we see in the night sky. The different colors of the auroras are determined by the types of atoms being excited. Oxygen atoms, for example, produce green and red lights, while nitrogen atoms can create blue and purple hues. It's a breathtaking reminder of the interconnectedness of our solar system, with the sun's activity directly impacting our planet in beautiful and awe-inspiring ways. The northern lights serve as a vivid illustration of the dynamic relationship between the sun and Earth, a relationship that continues to captivate and inspire us. Outro Cosmic Curiosity, keep exploring the universe. Thanks for watching. If you enjoyed learning these surprising facts about the sun, make sure to like, subscribe, and hit the bell icon for more fascinating videos. So keep that cosmic curiosity alive, keep asking questions, and keep looking up at the stars. See you next time.